Hello and Assalamu alaikum everyone. So at the end of this video, you should be able to solve optimization problems. So what is optimization problems? In optimization problems, we are looking for the largest value or the smallest value a function can take. In other words, we need to find the maximum or the minimum value of that function. But bear in your mind, sometimes you will also need to find the value that will maximize or minimize the function. Okay, so let's take a look at an example. So I have a circle like this, and then I want to draw a triangle inside the circle. Okay, so my question is, what is the biggest area of triangle that you can draw inside the circle? Okay, so this triangle can be drawn like this. Okay, it can also be drawn like this. Okay, but what is the largest area that you can have out of this circle? Okay, and the next example is I have a 1 meter cable over here. So this cable is 1 meter, and I'm going to make a rectangle or a square out of this cable. So my question is, find the value of length, find the length and the width that will give you the maximum area of the shape. Okay, so there are a few steps in which you can follow to solve optimization problems. So the first one is you need to identify the variable to be maximized or minimized. So for example, now you have y equal to x, z. And the second step is you need to express y into a single variable function. So now your y is in terms of x and also z. Okay, so for the second step, you need to express your y either in terms of x or in terms of z only. Okay, so you need to have either y equal to something x or y equal to something z. So there needs to be some information given by the question in order for you to do this step. Okay, and third one, you need to differentiate f(x) and then let your first derivative equal to 0 to find all the x values. Okay, and the fourth step is you need to verify the solution, find your second derivative, and substituting the value of x that you have found in the second step into your second derivative. So if the value is greater than 0, then you have a minimum. If the value is less than 0, then you have a maximum. Okay, so finally you need to get the optimum value if required. Okay, let's do example 1. A garden is to be laid out in a rectangular area and protected by a chicken wire fence. What is the largest possible area of the garden if only 100 feet of chicken wire is available for the fence? Okay, so first thing first, you need to draw a figure. So this figure will help you to understand the situation that you are in and to help you solve the question. Okay, so draw a rectangle like this. Okay, I'm sorry for my bad handwriting. Okay, so a rectangle like this, and then you will have a length of m and a width of n. Okay, so what is your first step? So first step is you need to identify the variable to be maximized or minimized. Okay, so there are no maximum or minimum word in this question, but you have largest. Okay, so largest means maximum. So you need to find the largest possible area, which means your first step, your variable, your equation is going to be, I'm going to denote A for area. So A is going to be equal to m times n. So area is equal to length times width. Okay, so your second step. So second step is you need to express area into a single variable function only. So what is another information given by the question in order for you to do this? Okay, so there is 100 feet available. Okay, which means that this 100 feet is the total length of the chicken wire. So your fence, the total length of your fence will be going to be 100 feet. Okay, so you have 100 equal to, so you have this one, m plus n plus n, plus n. So 100 is going to be m plus n plus n. Okay, so you have 100 equal to 2m plus 2n. Okay, and then factor out 2, you will have 2n plus n. Alright, so now you have 50 equal to m plus n. Okay, and I'm going to make m as the subject, so you are going to have m equal to 50 minus n. Okay, so you have an equation for m now, so just substitute m into your a. So a is equal to mn, so 50 minus n, so 50 minus n times n is going to be 50n minus n squared. Okay, so for the third step, you need to differentiate your area with respect to n. So you will have 50 minus 2n. Okay, and then let dA dn equal to 0. So you will have 50 minus 2n equal to 0, 50 equal to 2n, hence n is equal to 25. Then you need to identify whether the value of n that you have already found is maximum or minimum value. So you need to find your second derivative. So your second derivative is going to be negative 2. So negative 2 is less than 0, which means that n equal to 25 is maximum. Okay, and then your fifth step is you have already found your n. Now you need to find your m. So m is equal to 50 minus n. So 50 minus 25 is equal to 25. Okay, so now you have already found your m and n, but the question asks you to find the largest possible area. So area is going to be m times n. So m is 25, n is equal to 25. So your area is going to be 625 feet square. Alright, that's all. Okay, so example 2. The total length of wire used in making a cuboid framework as shown below is 96 cm. So find the maximum volume of the outline for the framework. So total length of wire is 96 cm and you need to find maximum volume. Okay, so I'm gonna leave you this example as a try out. So try this on your own time and come back to see my next video. Bye bye.